Hello viewers, in this video we will see how we can add two 16-bit numbers in assembly programming, and it is more specifically for 8086 microprocessor. So the problem with assembly is that we can add any number, but we get problems when we try to display that in the output. So this video is about solving that problem and making a more efficient solution. So first let's try to run the program. Okay, here you can see the output. It shows 4300, and as you can see we have added 300 and 4000. So it works for n number within the 16-bit range, as it does not cross the total of 16-bit. So let's try to add something else. 11,000, and let's put here 10,000. Okay, let's run it. Okay, you can see it is as simple as this. So now let's try to understand how the program is working. So you can see inside the data section we have taken a variable named ctr, and it is a 16-bit variable or a double word. And within the main code, there are actually two procedures. The first one is main procedure, and the second one is another procedure that helps us display the output. So you can see here that adding the two numbers is not a problem. We just moved a variable. We just moved a value, that is 11,000, into the AX register, and later we added it with 10,000. But we get problem when we display this output, because we cannot display the addition of these two numbers as a whole. We have to display that output as ASCII numbers. So after we added these two variables, we'll get 21,000, but we cannot display that at once. So I have made here another procedure. So the purpose of this procedure is to split out the digits from the addition that we get. So I am calling this procedure here, and let's move forward here. So you can see, okay, let's try to actually run the program, and we will go step by step so that we can understand the flow of the program. So from here, let's take a single step, and you can see the original source code that is in here. So it will show you which run or which line is now being run. So let's take a single step. Okay, so we have loaded that value and we have added, and you can see when we call the procedure, it takes us to this place. Here we have moved the value 0 to the counter or the ctr variable, which is short for counter, that I have written. And the purpose of this variable is that we will count the digits, the number of digits that are inside the total addition of this value. So it will be 1, 2, 3, 4, 5. So the final value of counter will be 5. So now let's move forward. So we have cleared the DX register, and we have also moved the value 10 inside the BX register. So we actually need the divide function here. So if we move again, and you know that when there is a value inside the AX register, and if we take another value inside another register, and if we divide it by that value, so the AX gets divided. And you know that for the 16-bit division, you will get the remainder in the DX register and the quotient inside the AX register. So when we divide the addition of these two numbers, which is 21,000, we get 0, which is the remainder inside the DX register, and we get 2100, which is the quotient inside the AX register. So let's move forward, and later we push that value into the stack. We are just saving that value, but it will be saved in actually the order that we divide. So now we are again clearing that the dx register, because this is a loop, and it will keep moving until the ax register is 0, or we don't have anything left to divide, and we are incrementing the variable ctr, so that we know that how many digits are there inside the final result. So let's move forward, and here we are comparing whether the result, which is the quotient, has become 0 or not. So if it becomes 0, that means we don't have any more digits, and from here we will jump to the section which is L1, and the L1 is right here. Okay, so this loop will run for few times. Okay, so as you can see, it is running. Okay, so we have found a match here, which means the value of ax, you can see the ax register is now 0. So now we have jumped to the L1 section, and here you can see that we are taking the number of digits, that is the CTR variable, inside the CX register. You know that CX register controls the loop. It will automatically decrement as we look through the L2 section. So now let's move forward here, and you can see the value of CX is 0, 5 now, right? Because we have moved the number of digits from CTR to CX, and you can see that the final output of this, the addition of these two numbers, will also have total 5 number of digits. Okay, so now let's move forward, and the pop command, this is used to retrieve those variables that we have saved earlier from the stack. So first we will have 1 and 1, that is 2. First we will have 2 inside the dx register. So let's run it. You can see now we have 2 inside the dx register, because the addition of these 2 is 21,000. So now let's move forward, and we are running the output function, and into 1, and you can see that we have 2 in the output. Now let's run it again. Okay, and you can see that the CX is decrementing automatically, and the loop will run until the CX becomes 0. Okay, so let's move to it. You can see that each of the digits are being displayed on the output. Okay, you can see the value of CX has become 1 now, and if we finish this iteration, it will become 0. You can see the CX is 0, so the loop won't run anymore. And now we have to exit the program. Okay, now you can see the program exited. It was as simple as that. So now you don't have to convert those again and again and do the ASCII adjustment. So this is a more easier and efficient way to add any number of bits. It can be 2 digit, 3 digit, 4 digit, or 5 digit. Okay, it's not a problem. You can also do that for 32-bit values as well. And here one thing we have to keep in mind, that these values that we get from the stack, that is 21,000, right? 21000, these are actually in decimal format, but we have to convert them into the ASCII range, because the output is only displayed in terms of ASCII data. So when we add 48 to any decimal, it becomes 0 to 9 in the range that is the defined range for ASCII 0 to 9. So when we are adding 48 and 2, it becomes 50. So the ASCII value of 50 is 2, and it goes on like this. So this is the end of this video. I hope this video was helpful. Thank you for watching.